Hello class, welcome to Unit 10, Video 1. Today we're going to start looking at exponential functions. Your learning targets for today are that you can graph exponential functions. So with our graphing, you are going to want to make sure you have out your graphing calculator so we can do that easily. You're also going to be able to write exponential equations of the form y equals ab to the x, and I can solve exponential equations. Okay, so those are our learning targets. So let's look at an example. We have Sam is working in a biology class with a petri dish of bacteria. He estimates he has a colony of about 25 bacteria. Assuming the entire population of bacteria doubles every hour, find how much bacteria Sam will have after 5 hours. Okay, so no time has passed. Okay, we're starting out with 25 bacteria. So at 0 hours, it's 25 bacteria. After 1 hour, if it doubles, we would have 25 times 2, 50. 2 hours later, we would have 100. 3 hours later, we would have 200. 4 hours later, we'd have 400 because we're just doubling. 200 times 2. 5 hours later, we'd have 800 bacteria. So to answer the question, it would be 800 bacteria. However, if I asked you to figure out, well, how many would he have after 20 hours, would you really want to sit there and write it out? Most likely not. So our exponential equations are of the form y equals ab to the x. A is the amount you start with. Okay, well, how much did we start with? We started with 25 bacteria. B as the rate at which it grows or decays. This one is growing at a rate of doubling, so my B is 2. So my equation would be y equals 25 times 2 to the x. If I wanted to figure it out for 5 hours, I would just take and plug in 5 for x. So just try it. Does this give us 800? So what you would do on your calculator is 25 times 2, then use our little caret, to the 5th. Oh, I didn't type in all of 25, did I? So I'm just going to go ahead. Hopefully you typed in 25 the first time. So second insert 5. There it is, 800. So if you type it in right, that equation will work. So we don't want to have to count things out all the time, so there is a nice exponential equation that you can use to solve problems like this. Okay, exponential functions we are going to look at, but let's just remember the functions we've covered so far this year. Our basic linear, it is a line. Remember that's y equals mx plus b. Our quadratic, y equals ax squared plus bx, not squared, just bx plus c. Then other polynomials, remember we talked about the number of degrees is the number of turns plus 1. So this one has 2 turns, 2 plus 1 is 3. So this is probably something with an x to the third. This one has 1, 2, 3 turns, 3 plus 1 is 4. Something that has an x to the fourth. This one has 1, 2, 3, 4. 4 plus 1 is 5. So these are all other polynomials like our linear and quadratic. Square root functions, things that have a square root in them. And then finally rational we covered last unit. Rational ratio, we have a fraction. Okay, so it's a function with a fraction. So that leads us into our exponential equations. Okay, standard form, like I said, is y equals ab to the x. Here's our properties, some important things to remember. The function is continuous and one-to-one, okay? Excuse me. To be continuous, remember when you draw it, you do not pick up your pencil. Okay, so all exponentials look something like this. This is a growth function. This one's a decay. They're also drawn below for us. So I didn't have to pick up my pencils. They're continuous. And one-to-one means that every x only has one y. Okay. The domain, so if you are asked for the domain on your test, which I do believe it is, you are, it's a set of real numbers. So my domain is all real numbers. Okay. The x-axis is an asymptote of the graph. So here's my x-axis. So there's really an asymptote here. It's really y equals 0. Okay. The range is a set of all positive numbers. A is greater than 0. And all negative numbers if a is less than 0. Okay, so range. It depends on what our a value is. But it's all positive numbers, so the way you'd always write your range is it's y is greater than 0. Because I'm never going to touch 0. It's only going to be numbers above 0. The graph contains the point 0a. That is your y-intercept. So if you look, this is a, this is your y-intercept. It's your starting value. It's your initial amount. The graph of y equals ab to the x and y equals 1 over b to the x are reflections across the y-axis. So for instance, if my a is 2, if my b is 2, then 1 over 2, they are reflected across the y-axis. So here's my y-axis. If I take and flip it, I will get this answer. Okay. One thing I would want to say is B. B is your rate. Okay, and it's really 1 plus or minus the rate. If it is growth, you take 1 plus your rate. If it's decay, you do 1 minus the rate. Okay. This one, I have the number 2. So this would be, I would use 2 if it said it was doubling in the equation or word problem. This is also, if you notice, as I read it from left to right, it's increasing, so this is a growth. So if your B is greater than 1, it's growth. This one, if you look from left to right, it's going down, so it is a decay. So if your B is in between 0 and 1, it's decay. The other thing that I would point out is this is a 1/2 rate, so this is what we call halving. Instead of doubling, you're getting cut in half every time. Okay. So those are our basics. There's a lot of information on here, so please, I hope you took some notes, wrote down some of the stuff that I have here. And if you have any questions on the basics of exponential functions, please come and ask. All right, so we want to sketch the graph. Okay, with exponentials, usually just going from -3 to 2 or -3 to 3 is a good way to graph it, but your x values will typically stay the same, and then we want to state the domain and range. Okay, based on the information I told you, you should be able to tell me the domain and range right now, but we'll graph it and then we'll look at it. Okay, my A is 3. Remember, your A is your y-intercept. So essentially, I'm going to have 3. And then this tells me that I am doubling. So guess what my next point would be? If I'm at 3 here, what's twice of 3? 6. 1, 2, 3, 6. Okay? But maybe you don't see that, so let's go ahead and graph it on our calculator. We have that tool to use. So if I want to graph this, I'm going to go to y equals. I would do 3 times 2, then I do my little caret to the x. Okay, I could go to my table, so second table set. I want to start at -3, and remember your delta table is what you count by. Okay, so now I'm going to go to table and graph it. Second table, there it is. So -3 is 0.375. The biggest one I want to look at is I had the order pair 0, 3 on my graph, and then 1, 6 is what I said. So those are on there. But if you ever need to, there are your values. So I'm going to write these down on my table. So 0.375, the next one is 0.75, the next one's 1.5, then times 2, because it's timesing by 2 every time, 3, then 6, then 12. And then I would do my best to plot some of these. So -3, 0.375, -2, 0.75, -1, 1.5, 0, 3, 1, 6, and then it would be way up here at 12. Okay, so there is my exponential graph. Biggest thing to remember is there is an asymptote here, which means I will never touch this line, so do not draw it past this line here. Okay. Then it also tells me to state my domain. Well, our domain, I said before, was all reals. Or you could write out all reals. Either way is fine. Okay, your range. I'm just going to recap really quickly. Remember, your domain's your x values. It's going to go all the way to the left, and it's going to keep going all the way to the right. Your range is your y values. So I will never touch 0, but I will be numbers greater than 0. So it's y is greater than 0. Right. Let's move on to our next one we need to graph. This one is, our b is 1/2. So this is cutting it in halves. So this is halving. So we're going to graph it, and then we're going to go ahead and find the domain and range. Once again, my A is 2, so that means at 0 I have 2. In this one, I'm cutting it in half every time, so it's half of 2? 1. So let's just make sure those are on there, and let's graph it. So we're going to go to y equals again. So we would have 2 times 1 divided by 2 to the x. Second table set, I still want to start at -3, so I'm going to look at my table. So at -3 it was 16, -2 is 8, 4, 2, 1, 0.5, and from there we go down. Just keep cutting it in half. One thing I will say, you could also just hit the graph button if you wanted to check to make sure you graphed it right. You could have done this on the last one. So when you hit graph, notice how I'm getting really, really, really close to the x-axis, but I will never actually touch it. If you zoomed in, you'd see that, and you'll never go below it. Okay. So we have -3 is 16. Then we got 8, 4, 2, 1, and 0.5. So I'll do my best to graph these. If it doesn't fit on there, don't worry about it. Like 16 is not going to fit on my graph. So well, that's really badly drawn. So make sure you look at the graph when I hit graph on my calculator. Should look like this. My window's a little different, but there you go. Okay, now when you talk about domain and range, domain is always the same. It's going to go all the way to the left and all the way to the right. So my domain is all reals. My range then is my y values. I'm never going to touch 0, but I'm always going to be bigger. So y is greater than 0. All right, so the next thing we need to talk about is exponential growth and decay. These are two things, these two equations are the same, and we've kind of already talked about them. But if we're growth, your b is really 1 plus your rate. Okay, if you're decay, your b is equal to 1 minus your rate. So something to keep in mind. The other thing about exponential growth, okay, your a is always greater than 0. Same thing with decay. What that's saying is you have to start with a positive value. You can't start out with negative. So your y-intercept is always bigger than 0. And your b is greater than 1 with growth, right? Because 1 plus r, that's going to make your b bigger. And with decay, your b value is in between 0 and 1. I totally wrote that wrong. I was talking and writing at the same time. In between 0 and 1, your b is. Okay, so if your b is 1.2 means growth. If your b is 0.8, that means decay. All right, with time, what happens to the value of a car? Is there a little bit of examples? You have some on your homework for tonight as well. Typically, the value of a car is a decay. The value will go down as time goes on. Gold. You hear people wanting to buy gold from you all the time. This is actually growth. A home is typically called an investment because most likely, unless the market crashes, the value of your home will go up. So there's growth. And lastly, technology. Okay, what happened to the iPads that you've previously had maybe? You've turned them in, you got newer. So the value of your technology decays. Or you go and try and sell your old cell phone, they don't want as much as you paid for it. They want less, so it's a decay. All right, so we have some equations we need to go ahead and decide. Are they growth or decay? Okay, well, just to note, my a value is 1 here, just because it's not written. But a is 1, and my b is in between 0 and 1. So if it's in between 0 and 1, that means it is a decay. On part B, my b value is 1.2. My 1.2 is greater than 1, so this one is a growth. Okay, so looking at the equations, that's how you can tell if it's growth or decay. Now we're going to go ahead and look at some word problems. Example 3. Suppose you buy a car for $15,000 and its value decreases at a rate of 8% per year. It says write an exponential function for the value of the car after X years. Okay, so we bought it for this. This is my starting, so that's my A. To figure out B, since it's decreasing, you take 1 minus your rate. So this is 8%, so you'd write it as 0.08. So your B is really 0.92. So y equals a b to the x is what we're modeling it after. So y is equal to my a, 15,000, my b, 0.92 to the x. Part B says, what will the value of the car be after 4 years? Well, x is the number of years, so I'm just going to plug in 4. If we go ahead and do that, so remember to get out, you can go second quick. 15,000 times 0.92 to the fourth tells me my value will be $10,754, and it's money, so rounded 2 decimal places, 89 cents. $10,754.89. Okay, so there is my answer for 3B. All right. Example 4, it says, suppose you start an experiment with 45 bacteria. That's your A value. And they double every hour. That's your B. Okay? They double every hour. When they tell you when they say double or having, that is your B. You do not need to do 1 plus or minus. Okay? So y equals 45 times 2 to the x. And that is it for part A. How much will you have after 4 hours? Well, it's x hours, so y equals 45 times 2 to the 4. If you type that in, you get 720. So you'll have 720 bacteria after 4 hours. All right, example 5. A radioactive substance decays hourly. Write an exponential function to model the amount of substance Y left X hours after 1 p.m. Okay, X hours after 1 p.m. So at 1 o'clock, that's like our starting time. So we're really saying that no time has passed. Okay, so we really have 0, 1,250. What does that tell me? This is your y-intercept, which tells you that is your A value. Okay, if no time has passed at 1 p.m., how many hours later is 4 p.m.? 3 hours. From 1 to 4, it's 3 hours. So I really have 310. It's an ordered pair. Okay, so we need to write an equation. Here is my A value, and here's an ordered pair. Remember, ordered pairs are X and Y. So if I'm using my equation, Y equals AB to the X, I know A is 1250, I know X is 3, and I know Y is 10. So I need to plug them all in and solve for B. So I have 10 equals 1250 times B to the third. To solve for B, I would divide both sides by 1250. So I'm going to just reduce, those zeros will cancel, so it's really 1 over 125 equals B to the third. Now, how do I get rid of something to the third power? Cube root. Okay, you can do the cubed root, and you might just be able to see that the cubed root of 1 is 1, cubed root of 125 is 5, but if you don't, remember you can use your calculator. Cubed root is under math, cubed root is number 4, and I would do 1 divided by 125, and it might tell me 0.2. If I wanted to leave it as a fraction, I would go math, frac, enter, and it's 1/5. So you could write 0.2 or you can write 1/5. So my B is 1/5. So to write my equation, it's Y equals my A, 1250, times my B, 1 over 5, whoops, to the X. So there's my equation for 5. All right, let's look at number 6. In 2000, the population of Phoenix was 1,321,045, and it increased to 1,331,291 in 2004. It says, write an exponential function that could be used to model the population Y of Phoenix. Write the function in terms of X, the number of years since 2000. So if we're saying since 2000, 2000 is 0 years since 2000. So I have this ordered pair, and 2004 is 4 years since 2000. Okay, so there are my two ordered pairs. This one is my y-intercept, so this tells me this is my a, this is my x, and this value is my y. So I need to plug it in and solve for b again. A times b to the fourth. All right, so I'm going to divide by 1321045 on both sides. Okay, and I'm not actually going to do that on my calculator. I'm just going to leave it. So I have b to the fourth is equal to this fraction. So in order to solve, I would take the fourth root on both sides. So b is equal to whatever this is. Okay, so on my calculator, in order to do that, I would hit the number 4, because fourth root is not just listed there. So 4, and then math, and then you see how number 5 is the x root. Since I type 4 first, it's going to make it the fourth root, and it would be 1,331,291 divided by 1321045. Enter, and this is an estimate of our b value. So I would recommend 3 decimal places to write down. So this 9 tells me this 1 has to round up to a 2. So my equation is y equals my a, 1321045 times 1.002 to the x. There's my equation. Okay. B says, suppose the population of Phoenix continues to increase at the same rate. Estimate what it would be in 2015. Well, remember, it's years since 2000, so take 2015 minus 2000. So we'd plug in 15. All right, so this is what we need to type in. Here's what I'm telling you you need to do. You need to use the exact value of b, which is the fourth root of this fraction. So when you type it into your calculator, you are going to do 1321045 times, arrow up and get the original b, the non-rounded one, to the fifth. This tells me the population. And actually, this one's even rounded. You have to use this one right here. So I'm going to retype it in. 1321045 times, grab the actual one you typed in, the fourth root, to the fifth. Oh, that's why I typed fifth, not 15th. So it would have worked to use the one I used before. I should have typed 15. There it is. 1,359,879.1. So this is people, so we shouldn't have any decimals. This one tells me to keep it as is. So my final answer for this, the population, will be 1,359,879 people. Okay, so just make sure you use your calculator, use the most accurate b that you can. All right, moving on to our last learning target. Okay, we need to solve exponential equations. Okay, this is number 7a. This one is pretty straightforward. Notice how our bases are exactly the same. Okay, if these are the same, that means my exponents need to be exactly the same. So in order to solve, I just take and set my exponents equal to each other. So I get 2n is equal to 3, and then I would divide by 2, so I would have 3 over 2. That's what n is equal to. Part B, though, not as straightforward. Okay, I would say to myself 64. Okay, I see this is a base 4. Can I rewrite 64 as base 4 something? Well, I know 4 squared is 16. So I'm just going to say, what is 4 to the third? That is 64. So I'm going to rewrite 64 as 4 to the third. So I would have 4 to the 2n minus 1 equals 1 over 4 to the third. Now I notice they're the same bases, but this one's a fraction. So now I need to use my rules of exponents. If I take it and move it to the numerator, what's going to happen with my exponent? It will become a negative 3. Now bases are the same, so that means my exponents have to equal each other. So I would say 2n minus 1 equals negative 3. If I add 1, I have 2n is equal to negative 2, and I divide, so n is equal to negative 1. And that would be my answer for example 7b. Okay, that is the end of Unit 10, Video 1. If you have any questions, let me know. Otherwise, have a great day, and I'll talk to you later.